Hello everyone, we are Team ICE. This is our final report of the question generation and answering project. Our system has two parts, question generation and question answering. The question generation process includes three parts, data preprocessing, yes or no and WH questions generation, and questions ranking. First, for the preprocessing part, we use NLTK sentence organization to select all sentences from the article. For each long sentence, to make the sentence more concise and easy to deal with, we split sentence by comma. Then we use a self-defined filter to remove sentences, including too long or too short sentences, and the sentences which contain special characters. For example, at the sentence in the slides, in recent years is less than 5 words, so we will remove this. By using Stanford parser, each sentence can generate a parse tree. The parse tree can help us judge whether the selected sentence have NP-VP structure. If so, we can use this sentence to build questions. Otherwise, the sentence will be dropped. For example, Hank's films also have grossed more than 4.5 billion at US and Canadian box offices, and more than 9 billion is NPVP structure. But the following sentence is not NPVP structure, so we will use the first sentence. Next is a detailed process of producing questions. For the yes or no questions, the most important thing is to find the predicate of the sentence. We use NLTK to get the part of speech tagging of each word. Thus, we can get the predicate of the sentence. We need to consider two different cases here. One is auxiliary verb and the other is notional verb. For auxiliary verb, we need to put it on the beginning of the sentence and remove the original word in the sentence. For notional word, we should add the prefix like do, does, did, has, or have at the beginning of the sentence, and then change the original word to infinitive, which is achieved by the WordNet lemmatized tool in NLTK. For WH questions, the idea is to replace the subject with who, what, when, or where. So we need to identify which kind of subject or object it is. To do this, we use NER tagging tool in the spaCy framework. According to the NER tag, we can determine which WH phrase to use. We just need to replace the original word by these WH phrases. After generating these two kinds of questions, to increase the difficulty of the questions, we choose to replace some adjective words with corresponding antonym words. We will randomly choose the antonym word from the whole antonym word set to make sure this kind of question is not too much. After that, we need to rank all the questions to get the final list. For yes or no questions, we give bonus to the questions where some words are replaced with antonyms. This is because we change the polarity of the sentence. It's hard to answer if the answering system doesn't have sentiment analysis. As for WH questions, we give more bonus to the sentences with pronouns. It is obvious that the answering system needs to find what the pronouns represent and analyze the relationship between sentences. Next is the question answering part. This part can be divided into three parts, preprocessing, candidate match, and answering to specific questions. First, we apply the same methods as we used in preprocessing before, which are sentences tokenization, sentences filtering, and word stemming. Then, we use sklearn to calculate TF-IDF so that we can extract keywords from each sentence, both in the questions and the article. After that, we convert questions and article into vectors and select the sentences in the article which has the highest cosine similarity with the question. In the process of classification, we use the regular expression to divide the questions into binary and WH questions. For the binary question, by sentiment analysis, we need to judge whether the question and the answer have the same sentiment. In this process, first, we find the number of negative words from the sentences. Since the negative words are limited, we just create the set manually. Meanwhile, we check if every word in the question exists an antonym in the answer by the WordNet. With these steps, we could answer yes or no questions correctly. As for WH questions, after selecting candidate sentences, we compare the candidate with question to extract the closest part. To be more specific, where and when questions need the location and time as the candidate answer. Then we traverse the sentence and find words with specific entity labeled by NER. For who and what questions, we first convert the question to the declarative sentence, then compare the grammatic structure between the question and the candidate through dependency tree, and then get the correct part. If the answer we get is pronoun, we have to get the noun word which represents the same entity. Coreference resolution is a task of finding all expressions that refers to the same entity in a text. Since this method takes long time and has poor performance, we just look ahead and search other nouns in near sentences as candidates answer. As the example in the slide, the answer for who problem is it, which refers to the entity in the previous sentence. The last part of the presentation is the evaluation of the entire system. We first use our system to generate 100 questions from the wiki file in the server and generate the answer according to the questions. Then we use human evaluation to judge the precision of the generated questions and answers. From the results, we can conclude that our system can achieve over 80% in both question and answering part.